This is a radius r, v and omega. No, they're going to collide. Is that okay? No, so it will become like a badminton. I don't know what will happen afterwards. That's what we have to do. So this is O1, you write it, O2, O1 and O2. Mass of this is m, and this was that particular point. Just make observation of diagram. I think you can manage very comfortably. So this will become now a racket, no? Stilling. And it's a rigid body now. The disc plus rod is a rigid body. And what is the property of center of mass? What is the property of rigid body? Set free to rotate, it will rotate about center of mass. Where do center of mass of this racket will come? Where the center of mass of this racket? This is mass m and radius r. Mass m and length is how much? This is r and r, no? So where the center of mass of system will come? Center of mass of system will come here. I'm showing C. This is the center of mass. What is C? C is the what is the property of rigid body? Set free to rotate. You look at the disk. Why it is rotating about O1? There's a property of rigid body. If you set free to rotate, rotate about center of mass. No, the disc plus rod, when they collide, they'll become a racket. They'll become rigid body. So at what point they'll rotate? They'll rotate about the center of mass. See that one. So why not O1? It's not a center of mass of system. Why not O2? Not center of mass of system. Sir, I'll make the mass of the disk 2m. Then this is m. Then the center of mass will shift here, will somewhere here. Then it will rotate about that particular point. Okay, got this? Irrespective of that one. Definitely open the center of mass should lie between O and O2. So where the center of mass lies, about that point it will rotate. Sir, I'll make 2m. Then center of mass will come here. Then will it rotate about this point? Yes, it will rotate. So this, can it rotate about such a point? Yes, it can happen. See, that's what. Be ready for only this one. So the problem, I could have made little bit more complicated, so you'll get confused. That's why I just took m and m. So if I make this is 2m, this is m, the center of mass will be here. It will rotate about this. Getting the idea? So don't compromise. The rigid body must rotate when set free to it, should rotate about center of mass. I'll take it out this. Oh, no, come for this one. So this will have velocity Vc and omega c. We'll apply conservation of angular momentum about point C and we'll write the equation. LCIZ, LCZI equal to LCZF. Initial angular momentum. So this is what that C will come here, no? So then due to translative motion, MVR, due to rotating motion, I naught omega. I think you have to be careful. The rigid body is not rotating about C. About what point it is rotating? It is rotating about, its own center. So this is a conservation of angular momentum formula. So then equal to, then what you're going to write? IC omega. IC what? Moment of inertia of the total rod plus disk it is. Plus center of mass of the system 2m Vc. Okay. Yeah, not needed, no? This much only. Now what is IC? We'll calculate separately. What is IC? Moment of inertia of the disk I naught plus mr square plus that of the rod m 2r whole square by 12 plus m into r square. Able to manage. What is moment of inertia of the disk about axis passing points? Parallax theorem, IO1. I'll write equations clearly. because there's a concept. No? The moment of inertia calculation is what a concept. So I see what it is equal to IO1 plus MR square plus IO2 MR square. What is IO1? Moment of inertia of disk about its own axis. Substitute that, you'll get IC. And V quote R omega is given. And what is I naught? I naught is IO1. Okay, I think already I written, no? Yeah. Very small thinking, nothing to do. Now with this what will happen? We'll get the omega C. But sir, how to get VC? Still the problem is not at all, no? How to get that VC part? Applying conservation of linear momentum. Initial momentum mv, final momentum mvc plus mvc, or 2mvc you write it, total mass of this one. So vc equal to v by 2. So all this you'll get the omega c. Okay, agreed. Okay, now after getting this, is asking calculate loss in kinetic energy. How to calculate loss in kinetic energy? Initial kinetic energy we know. So initial kinetic energy will be final kinetic energy IC omega c square by 2 plus 2m vc square by 2. Kf will be less than Ki. Where do this energy gone? Anybody answers? Where do this energy gone? Yes, due to that impact, no? Because when it is injured, energy will be lost in most of the cases. I gave one problem where suddenly injured, there was no loss in energy. Yes, it happens. But here what happened? Due to sudden inch in the sense, what happened? They get stuck, no? So because of that, what happened? There'll be some energy will be lost. Why is energy lost? Because like some sort of like when it gets stuck, what will happen? Sir, what will happen? That energy will convert into heat. That's all. Because they are rigid, no. So no question of deformation. So it should be converted into heat. So where do this delta K will? So delta K converted as heat. If V equal to eta or omega, so he's asking that one. So kinetic energy is minimum, find eta. So you should differentiate this, huh? Work out, it's a mathematics one. I'll upload the answers later on. Now, intentionally I brought it. This instead of rod, another disc come. Let it be. Any other rigid body. Okay, finish over. Sir, even the rod is moving. Let it be that one. No problem. Take the next one. Some spring will bring it. Huh? Till now, I think we didn't brought the spring idea. Carefully read the question. Protrusion. Protrusion. Sorry, this protrusion means